Hello, I'm Win, and I'm going to be doing my presentation on Triton 2017. So, in August of 2017, a petrochemical facility in the Middle East was the target of a cybersecurity attack involving a malware known as Triton, and the exact identity and function of the facility were not disclosed. But the attack was linked to a Russian state research center. The attack was the result of a buffer overflow vulnerability that was exploited to install a remote access Trojan horse, also known as a rat. So there are a few different reasons that I wanted to research this specific attack. It was unique in quite a few different ways, while also being applicable to our class content. So firstly, the attack was very dangerous, and it had the potential to cause significant physical damage or loss of life. And the explicit targeting and attempted disabling of SIS systems at industrial plants had not been attempted before. And for this reason, Triton has been described as the world's most murderous malware. And I will cover what SIS systems here in a bit. And Triton malware has, since the attack, been deployed against more US partners in the Middle East. And in fact, the hackers behind the malware have been reportedly scanning and probing facilities in the United States as well, meaning that the malware is still an imminent threat. And as I mentioned, the attack was the result of a buffer overflow vulnerability, so it's a real-world example of a concept we've been learning about in class. So I'm going to introduce some of the details now. The Triton malware, also known as Trisis, was designed specifically to target and manipulate industrial safety systems, which you can see on the right how those are kind of constructed. And these types of systems are vital to maintaining a safe working environment at critical infrastructure facilities. And during critical events like system failure, they ensure that when a facility is shutting down, it does that while the limits are still considered safe. So it ensures a safe shutdown during emergency situations. And the Triton 2017 attack targeted a controller of the facility's industrial safety systems. And it's speculated that the attack may have intended to speed up the facility's components to cause an explosion, putting lives both inside the facility at risk and in the surrounding areas. And so I mentioned, the attack was linked to a Russian research facility, but it has also been determined that the attack was likely backed by a nation state. And I will say that just because the malware itself is linked to the Russian research facility doesn't mean that the attack was of Russian origin. That's just where perhaps the code could have been created, the malware. But the attack did match attacks seen from Russian, Iranian, North Korean, US, and Israeli nation state actors. So the attack was not normally what you'd see from the average cybercrime group, and it was created and tested using software that is not widely available. Oh, I also wanted to mention that this attack could have been done for a few different reasons, especially considering the attack has been linked to a nation state. It could be politically motivated. The attack could have been intended to sow fear and doubt in the ability of these important infrastructure facilities that are becoming more and more prevalent in our daily lives. And the attacks also could have been testing for practice because, as I mentioned, the attackers have been scanning more facilities in the United States and in the Middle East, so this attack could have just been, practice for further attacks. Now, moving on to the attack itself, as I mentioned, the attack utilized one of the most common cybersecurity exploits, a buffer overflow attack. And a buffer overflow is an anomaly where a program, while it's writing data to a buffer, executes past that buffer's boundary and writes into subsequent memory, where it's not supposed to be. And so the Triton attack exploited a buffer overflow to write malicious code into memory. And the attack was executed by exploiting this overflow to install a remote access Trojan in this case. So basically, this remote access Trojan was written into memory, and then once the rat is activated, it allows an attacker to remotely gain administrative control of a target computer. And in this case, the rat was used to give privileges to the remote attacker that provided that administrative control of an engineering station. And on the right shows kind of what happens in a buffer overflow attack. So with the RAT installed, the attackers executed a 0-day privilege escalation vulnerability in the SIS firmware, which elevated the malware code to obtain read, write, and execute privileges, which means that it had pretty much all permissions. And the attack then attempted to reprogram the facility SIS controllers to potentially cause an explosion. And a key aspect of this attack is that the vulnerabilities were the result of a breakdown between the organization's IT and OT network operators, and the security controls had not been properly tested, and I'll get into that right now. So this is kind of a diagram of the network that was in place during the attack. So basically the malware initially infected the IT network in the top right, and then once the RAT was activated, it was able to move in the OT network where it infected a workstation on one of the controllers. But in order for it to do that, it had to move through this DMZ, or demilitarized zone. And that's where this vulnerability was. So there was no clear definition of whether the IT team or the OT team needed to ensure that the security controls in the DMZ had been properly implemented and were effective. And so that's what led to the vulnerability, where the RAT was able to move from the IT to the OT networks. And the DMZ is basically just a middle ground that ensures greater protection of networks, basically. And so that was violated. Okay, as a result of the attack, thankfully there was not any severe damage or injury. And this is because the SIS controllers detected an anomaly and entered a fail state which shut down operations before the intruders could launch an attack, this prompted the owners to investigate. So despite no severe damage, there were still some notable consequences of the attack. So there were outages for at least one full week at the plant, and the exact cost was not made public. However, it was likely very expensive considering how long the plant was offline. And the exact type of facility was again not disclosed, but the outages resulted in a service failure for those relying upon the facility for the week that the plant was affected. And inherently, when people rely on something that they realize is vulnerable to attacks, this increases public fear. And there has been a growing public fear that at some point there could be a massive attack that takes down the public infrastructure. I mean, we've all heard it. An attacker may try and take down the grid. And this kind of fear surrounding infrastructure has been steadily increasing in the general public, and this attack only contributed to that fear. So the attack also triggered significant research and analysis aimed at developing solutions to secure the vulnerabilities of such systems. And the U.S. Department of Homeland Security actually said that it was looking into the matter to assess the potential impact on critical infrastructure. And thankfully, the breakdown between the organization's IT and OT network operators that resulted in the compromised workstation was resolved, which should in theory prevent future attacks. So, in conclusion, Triton 2017 was a dangerous attack that resulted in a very fortunate outcome. The malware was detected before doing serious damage, and this kind of attack was novel, targeting SIS systems and industrial plants that had not before been subject to such exploitation. And such attacks could become increasingly common as the world continues to build important infrastructure facilities. And in fact, probing for such attacks has been ongoing, as I mentioned. As a result, there has been increased research and awareness into both the Triton software itself and the vulnerabilities of such industrial plants. And the attack highlights the constant struggle against the common buffer overflow attack that has time and again been exploited by attackers. But thankfully, it seems that the facility in question has taken responsibility for the gaps in its security, and therefore such an attack at that specific facility should no longer be possible. However, this is a lesson for other industrial facilities that will hopefully result in more proactive defensive behavior. And public infrastructure is and will remain one of the most important components of society, and therefore guarding against attacks like Triton will be imperative to all such facilities. So, moving on to my questions. The first one is, what makes the buffer overflow vulnerability so dangerous? In this example, how did a buffer overflow vulnerability open the door to further exploitation? And these are both multi-part questions. The second one is, why is it important to guard against cybersecurity attacks that target large industrial facilities? And what kinds of harm could result from a successful attack against facilities like this? Okay. And then these are my sources. It's 2 pages. Okay, thank you.